December 1944, in the frozen forests of the Ardennes, German engineers captured something that would forever change their perception of American engineering. An M4A3E8 Sherman, nicknamed Easy 8, had been abandoned by its crew after an artillery attack. What happened in the following 3 months in the Wehrmacht's testing laboratories would reveal a truth so disturbing that it would be kept secret for decades. The same Germans who created the fearsome Tiger and the sophisticated Panther were about to discover that they had completely underestimated their American adversaries. The tank they considered inferior on paper was about to humiliate them in a way no German commander had ever imagined possible. The M4A3E8 Sherman arrived at the German testing grounds in Kummersdorf as a common war trophy. To the Wehrmacht engineers, accustomed to the complexity of their own designs, the Sherman seemed primitive at first glance. Its armor, only 2.5 inches thick at the front, contrasted sharply with the 4.5 inches of the Panther. Its 76mm gun seemed modest compared to the fearsome 88mm of the Tiger. But Oberingenieur Klaus Richter, a veteran of the Panzer IV development programs, noticed something peculiar when he examined the interior of the American vehicle. Every component seemed to have been designed not to impress, but to function. The transmission was surprisingly simple. The 500-horsepower Ford GAA engine was robust without being excessively complex, and the entire electrical system followed a logic that even a novice mechanic could quickly understand. The first endurance tests began with typical German skepticism. Richter's team subjected the Sherman to conditions that would make any German tank sweat oil. They forced it to operate continuously for 72 hours at temperatures of -20 degrees Fahrenheit, simulating the worst conditions of the Russian winter. They expected the American engine to fail within the first 12 hours, as often happened with their own Tigers under similar conditions. But the Ford GAA continued to purr smoothly, maintaining stable operating temperature and consuming fuel consistently. The HVSS suspension system, which initially seemed excessively simple, absorbed impacts that would break the torsion bars of German panzers. After 3 days of mechanical torture, the American Sherman still ran as if it had just rolled off the production line in Detroit. The real revelation came when the Germans began timing repairs. A typical Panther, when suffering a final drive failure, required 8 to 12 hours of specialized work to return to combat. The same simulated failure in the Sherman was corrected in less than 2 hours by mechanics who had never seen the vehicle before. The American modular system allowed entire components to be replaced in the field, while German tanks often had to return to rear workshops. Richter meticulously documented every repair, every part replacement, every minute of downtime. The numbers that emerged from his reports painted a devastating picture of American logistical superiority. While a Tiger spent an average of 40% of its operational time in maintenance, the Sherman remained available for combat 85% of the time. The most humiliating test came when the German team decided to directly compare the MTBF mean time between failures of the Sherman with their own tanks. They subjected 3 vehicles to identical conditions: the captured M4A3E8, a newly manufactured Panther OSF-G, and a veteran Tiger I that had been completely reconditioned. During 6 weeks of continuous operation, simulating combat patrols, forced marches, and tactical engagements, the results were unequivocal. The Panther suffered 17 significant mechanical failures, including 3 complete final drive breakdowns that left it immobilized for days. The Tiger accumulated 23 failures, with chronic steering system problems and engine overheating. The American Sherman recorded only 5 minor failures, all corrected in less than an hour each. Its MTBF of 240 operational hours surpassed the Panther by more than 300%. Richter's reports reached the German High Command in March 1945, causing an awkward silence in the War Ministry's meeting rooms. Albert Speer, upon reading the data, reportedly commented bitterly that the Germans had spent years pursuing technical perfection, while the Americans had mastered the art of practical efficiency. The Sherman was not superior in firepower or armor protection, but its operational reliability made it a much more dangerous adversary than any paper analysis could suggest. A tank that functions consistently is worth more than 10 supertanks that spend half their time in workshops. This painful lesson came too late to influence the course of the war, but it revealed a fundamentally different design philosophy that the Germans had completely underestimated. German documentation revealed technical details that impressed even the most experienced Wehrmacht engineers. The Ford GAA engine, derived from aircraft engines, operated with tolerances that allowed efficient functioning even with low-quality or contaminated fuel. The Germans discovered that they could mix up to 15% water into the fuel without significantly affecting the performance of the American engine. Their own Maybach engines failed with just 5% contamination. The Sherman's electrical system used standardized components that could be found in any American Jeep or truck, while German tanks relied on specialized parts that were often in short supply. The Sherman's automatic transmission, initially ridiculed as technology for lazy people, proved capable of operating smoothly even when operated by inexperienced drivers, drastically reducing mechanical wear. The most disturbing aspect of the German tests was the discovery of the American philosophy of preventive maintenance. While the Germans designed their tanks to last decades under ideal conditions, the Americans designed theirs to be easily replaceable and repairable under field conditions. Each Sherman came with a maintenance manual that an ordinary soldier could understand, illustrated with clear diagrams and step-by-step procedures. German manuals required specialized technical knowledge and often assumed access to tools and facilities that simply did not exist on the front lines. Richter calculated that an average American mechanic could keep 3 Shermans operational with the same effort required to keep a single Panther running. This disparity in logistical efficiency explained how the Americans managed to keep thousands of tanks in simultaneous operation across multiple battlefronts. In his final reports, dated April 1945, Richter made a confession that would echo through the corridors of the German command. "We built engineering masterpieces," he wrote, "but the Americans built war machines." The M4A3E8 was not technically superior to German tanks in any individual category, but its combination of reliability, ease of maintenance, and operational availability made it a devastatingly effective weapon system. The Germans had focused on creating the perfect tank for perfect conditions, while the Americans created the tank suitable for the imperfect reality of war. This fundamental philosophical difference explained not only American numerical superiority, but also their ability to sustain high-intensity operations for prolonged periods without significant degradation of combat capability. The final irony of the German tests was that they confirmed something American soldiers already intuitively knew. The Easy 8 Sherman was a reliable workhorse that rarely let them down when they needed it most. While the Germans struggled with broken Tigers and burning Panthers, Sherman crews could trust that their tanks would bring them home. The superior MTBF of the M4A3E8 was not just a technical statistic. It was the difference between life and death for thousands of American soldiers. The engineers in Detroit, working under mass production pressure, had inadvertently created one of the most reliable tanks in military history. This lesson about the importance of operational reliability over theoretical technical superiority would influence the design of American military vehicles for decades, establishing principles that still guide modern military engineering. The German documents on the Sherman tests remained classified for decades after the war, buried in archives that few historians could access. When they finally came to light, they revealed an uncomfortable truth about the perceptions of the time. The Germans, masters of precision engineering, had been outmaneuvered by Americans who prioritized practicality over perfection. The M4A3E8 Sherman, with its superior MTBF and design philosophy geared towards the reality of the battlefield, represented a fundamentally different approach to mechanized warfare. It was not the most powerful or most armored tank of World War II, but it was, without a doubt, one of the most effective. The reluctant confession of the German engineers serves as a lasting reminder that, in war, reliability often triumphs over complexity, and that sometimes the best engineering is that which simply works when it is most needed.